For most questions involving standard deviation, we can apply the very informal definition shown here. It says that the standard deviation of a given set is approximately equal to the average distance that each of our data values is away from the mean. Let's use this definition to examine some sets. Set A. Here we see that the mean of these three numbers is 11. So 10 is 1 unit away from the mean, 11 is 0 units away, and 12 is 1 unit away from the mean. Let's compare this with set C. Here, the mean is 0, so negative 2 is 2 units away from the mean, 0 is 0 units away, and 2 is 2 units away. As you can see, the numbers in set C on the average are further away from the mean than the numbers in set A. If we were to compare all 5 sets in this manner, we would see that set C has the greatest standard deviation. So this is our answer. Now, for the purposes of the GRE, we can think of standard deviation as being a measurement of how much the numbers in a set differ from the mean of that set. So here we have set A with a mean of 0.5 and set B with a mean of 5. Notice that the numbers in set B differ from the mean more than the numbers in set A. As such, the standard deviation of set B must be greater than the standard deviation of set A. So column B is greater than column A, and our answer is B. This question can be solved quickly if we recognize that 24 consecutive odd integers constitutes an arithmetic sequence. Now, an arithmetic sequence is one in which the same number is added to each element to get the next element. So here are some examples. This is an arithmetic sequence because we add 1 to each element to get the next element. In this arithmetic sequence, we add 2 to each element to get the following element. In this arithmetic sequence, we add 4 to each element. And in this one, we add negative 10 to each element to get the following element. Notice that in all of our arithmetic sequences here, the mean is equal to the median. In fact, we have a nice rule that says for any arithmetic sequence, the mean equals the median. So in our question, we're told that the mean of our 24 consecutive numbers is 48, so the median must be 48 as well. Our answer is C.
The average, or the arithmetic mean weight of 18 automobiles is 3,500 pounds, and no automobile weighs exactly 3,500 pounds. And so we want to compare the number that weigh more than that with the number that weigh less than that. Well, it certainly could be true. It could be true that they're equal. That is one possibility. We could have 9 that weigh 4,000 pounds and 9 that weigh 3,000 pounds. And then that average would be 3,500, and then they'd be equal. So that certainly would work. Or we could have the cars that are over be most of them. Let's say 17 of them are just over. 17 of them are, say, at 3,600. So on this side, we've added 100 17 times, so we need to subtract 1,700 on the other side from 3,500. 35 minus 17 is 18. This would be one car that weighed 1,800 pounds and 17 cars that weigh 3,600 pounds. Or we could have most of them be less. We could have 17 of them be 3,400 pounds. We've taken away 17, so we need to add 17 on this side. That would be 5,200 pounds. One really heavy car with that weight. And so we could have more in column A or more than column B, or they could be equal. And in fact, from this information alone, there's no way to determine the number, whether there are more that are above the mean or more that are below the mean. It could be different for every scenario. Because we cannot determine it, the answer is D.
To begin, we're told that the average of 4 numbers is 4a plus 16. So we can use this rule to determine that the sum of those 4 numbers will be equal to 4 times the average of those 4 numbers. Then we add a 5th number and the average changes. So we can determine that the sum of those 5 numbers will be 5 times the new average of those 5 numbers. So now we know that the 5th number will equal the sum of the 5 numbers minus the sum of the 4 numbers, which is equal to 9a plus 36, which is equal to e.
On a certain standardized test, the mean is 180 and the standard deviation is 35. Which of the following is within 2 standard deviations of the mean? So 1 standard deviation is 35. 2 standard deviations would be twice of that, 70. And so let's think about this. The mean is here at 180. 70 plus 180 is 250. 70 minus 180 is 110. And so any score between 110 and 250 would be within within 2 standard deviations of the mean. So 75 and 100 are not in there. 150 is, 200 is, 225 is, 275 is outside of that. And so just C, D, and E, those are the 3 scores that are within 2 standard deviations of the mean. Okay, this is kind of an out-of-the-box question. First of all, notice that we have 2 16s in the set. So right away, we know that the mode equals 16. What would it take for the median to be 16? Well, let's just write these numbers in order. We'll space them out a little bit. 9, 13, 16, 16, 23. And so we'd want to put the x somewhere on this side. Now we don't know whether it's going to be bigger than 23 or smaller than 23, but we'd want to put it on that side so that we had 2 16s in the middle, 2 numbers below 16 and 2 numbers above 16. And that would be enough to guarantee that the median also equals 16, so the median would equal the mode. Now the tricky one is the mean. If we want the mean to equal 16, then one way to think about it is we'd have to add all those numbers up and then add x and then, we could find the sum maybe, but that's a long calculation. Let me show you a much easier calculation. Think in terms of the distance from the mean. Sometimes this is called the deviation from the mean. We're just going to subtract 16 from all of these numbers. So if we subtract 16 from these two, we get 0. They have a distance of 0 from the mean. If we subtract 16 from 13, we get -3. It's 3 below the mean. If we subtract 16 from 9, we get -7. We subtract 16 from 23, we get +7. Lo and behold, these two cancel each other out. 9 and 23 have an average of 16. And so to get the whole average to be 16, we'd need something that would balance out the 13. Well, that's at 3 below the mean, so we'd need something at 3 above the mean, or in other words, 19. And so if x equals 19, then the mean equals 16. And so the mean equals the median equals the mode. And so the value of x that we want is 19.
Okay, loosely speaking, we can say that standard deviation is a measurement of how dispersed a set of numbers are. So if we examine our 2 sets here, we can see that the 2 first numbers of each set differ by 1, the second 2 numbers of each set differ by 3, and the outside numbers differ by 4. So from this, we can see that both sets are equally dispersed, so our answer must be C. Our goal here is to find the average of w and x. In other words, we want to find the value of w plus x divided by 2. Let's see what we can learn from our equation. Notice that on the left-hand side of this equation, we have 2 fractions. We can often gain valuable insight into a question by combining fractions into one fraction. So let's do this here. To begin, we'll need to rewrite these fractions with a common denominator. Our denominator here will be wx. Now that we have the same denominator, we can add our numerators. Now notice that in the denominator we have wx, and we're told in the question that wx equals y. So we'll replace wx with y. Now notice that we have 2 equal fractions, and both fractions have y in their denominator. From this we can conclude that their numerators must be equal. And now we see we can divide both sides of this equation by 4 to get x plus w equals 1. Now notice that in our average formula, we need to know the value of w plus x. We now know that that equals 1. So we see here that our average becomes 1/2. So the answer is A.